Kia ora, Year 11 and 12. This is the toughest question in Assignment 5. It's from the summer of 2017 and it's the very last question in the A-level paper. So you kind of know that it's going to be hard before you even look at it. But I want to talk about what you do when you see a question like this and what can make you know where to start. So let's read it through slowly and with a highlighter. We've got two complex numbers, u and v. Sorry about the background noise. We're taking down a whole lot of camping gear in our living room, so apologies for that. So u is equal to this complex number here, and v is equal to this complex number here. First thing I see is that they're both in quadrant 1, so that's good. I can visualize that better. And then we're told that they're points A and B in a diagram. So already you should be thinking, I'm going to go and draw that diagram pretty carefully. And then we've got a third point in quadrant C, which lies in the first quadrant, and it's such that this, right, two conditions. BC is equal to 2AB, so from B to C is twice as long as from A to B, and the angle ABC is 90 degrees. So we have to find where that point is, and then we have to give our answer as a real and exact thing. So one person so far has managed to get there, but using their calculator. This is a question that you need to do basically without a calculator. So before we start, we're going to roughly sketch a bad graph before I show you the good one from the model solutions. So let's see what we're talking about. Suppose we've got 2 points, one here and one here. So this is u and this is v. Now what are we looking for? Well, we've got to find a third point such that, so that's point A and that's point B. BC is equal to 2AB. So there's AB. We know we can find the length of that line. That's not hard. BC is equal to twice that length, and angle ABC is equal to 90 degrees. So C could be in one of two places. It could either be sticking up here, so it could be that long, and it's out here 1, 2. Or it could be here, and it could be angle 1, 2, and it could be down here. But we know that the point is in the first quadrant, so we're looking for this point up here. So how are we going to get there? Well, there are probably lots of ways to solve this problem, but here's the way that I did it. I looked at this. I'm going to try and take the pink stuff off. No, I don't want to take all that off. Let's try again. Oh, where's my grid gone? Okay, so here's what we've got. We've got u and v, and soon I'm going to draw a good diagram. We're going to want to take this line length here and we want to rotate it, right? So if we can rotate that line and whack on 2, then we're going to be there. So think back to all of that really early stuff we did on complex numbers. There was one lesson where I made you do some easy examples and we talked about rotation. So let's start with another complex number here, and this is 4. So let z equal 4. How can I rotate it that way? How can I rotate 90 degrees anti-clockwise? Well, what I need to do is to times by negative I. So that's one of the big ideas in this question, is that to do rotation, we can multiply something by negative I. But what do we need to rotate? Well, we need to rotate this thing here. But this is v minus u. So the first step is going to be to figure out what's v minus u. Right? But that's going to be easy because we know v and u. And then we're going to want to have a starting point here, and we're going to add on 2 lots of that v minus u. So a lot of the ideas overlap with vectors. So I'm going to now move on to putting up some nice word solutions. Right, so somewhere here, where are we? Where's it gone? Right, so this is the beautiful diagram that I did, and I did it basically to scale using my ruler. So on your calculator, we can easily do v is equal to 3 plus 2i. So I've marked the scale out 1, 2, and 3. Now, not enough of you are doing nice scale diagrams yet. I want you to start using, if not a ruler, then something close to it to get this pretty accurate. So 3 plus 2i was the first thing I marked on here, and that's point v. Now, u is going to be a little bit trickier, but if you grab your calculator, you can get an approximate value for 2 root 3i, and you can see that a is going to be up here. And C, we've figured out from before, is in quadrant 1. So we're going to draw that on here. So take your ruler, draw that line on, rotate it, and put that point up about here. we know that we've got to be in the first quadrant, so that's a big help. We don't have to work out another one down here. Although, you're going to see once we get to the end, that wouldn't really be so hard. Let's get rid of the pink now. Okay, so that's your drawing. What am I going to do now? Well, I need to figure out this thing here. So it's time to actually do some complex numbers. Let's work out v minus u, because that's going to give me basically the vector from A to B. Right, well, AB is 3 plus 2i minus this one. And when we work that through, we get this. Okay, so that's not hard. The hard part in here is thinking about what to do. So we're going to want to rotate that. And we're going to rotate it by I. Right, so now we're going to do v minus u times I. And that's going to get me this bit here. They're meant to be the same length. So v minus u times I is equal to 2i plus 2 minus 2 root 3i times I, which gives me 2i plus, what have I done? No, that was I. So this is now I squared. Sorry, 2i plus 2 times negative 1 plus 2 root 3i. So that gives me 2 root 3 minus 2 plus 2i. So I need to take that now and I'm going to add it on to this point here. But I don't just want one lot of that, I want two lots of that, because we know that length BC is equal to 2 times AB. So this is quite a different way to think about complex numbers. Right, so we've done that. And now we're going to take 2 times that thing, and we're going to add it on. So in here, V is my starting point, so here's U and V. So we're starting at V, 3 plus 2i, and then we're adding on this bit up here. So that gives me my final answer of 4 root 3 minus 1 plus 6i. Right, really keen to hear if any of you have found cool other ways to do it. You can try and do some stuff like this with Pythagoras. That was the other way I thought about it when I first saw it. But I tried that pathway. This is last year when I first saw the question, and I got nowhere pretty fast. So I think thinking about it as more like a vectors problem helped me a bit. Okay, thanks for watching. I'll do some of the easier questions in a few minutes.